Welcome to today's Explainer. I am super thrilled you're here because we are looking at something literally game-changing today. If you're a massive fan of incredible room-filling audio, but, completely allergic to the massive price tags that usually come with it, you are in exactly the right place. We're going to break down exactly how you can build a hugely powerful 100-watt home stereo system totally from scratch and do it on a ridiculously tight budget. We're pulling from top DIY audio experts to show just how accessible audiophile sound actually is.
Okay, let's dive into this, because this right here is the central question driving our whole explainer today. How in the world do you build a pristine 100-watt stereo for roughly half the usual retail price, and do it without sacrificing even a single drop of audio quality? Well, the secret is all about ditching bulky, outdated tech and embracing highly efficient, modern components. It is an absolute game changer for anyone into DIY audio.
To answer that question, we're going to follow a really straightforward roadmap. First up, Class AB versus Class D. Second, the required main components. Third, cabinet and board arrangement. Fourth, audio control wiring. Fifth, power supply and connections. And finally, number 6, final testing and the result. Let's get to it.
Section 1. Class AB versus Class D. Let's contrast the old, expensive way of doing things with a much more elegant, modern solution.
And this brilliantly illustrates exactly what we're talking about. See, a traditional 100-watt Class AB amplifier requires massive, heavy transformers. And because it spits out so much heat, you got to buy cooling fans and these giant metal heat sinks, which means you need a huge cabinet to hold it all. All that extra hardware easily inflates your cost up to maybe 6,000 or 7,000 rupees. But look at the elegant alternative here, Class D. It's insanely efficient, generates practically zero heat, so no fans are needed, and it runs on a really compact switch-mode power supply. Because of all that incredible efficiency, the total cost for this entire DIY Class D project is under 3,500 rupees. Seriously, half the price of a traditional build. And here's the absolutely crucial takeaway. Cutting the budget like this does not compromise your audio quality at all. You're getting top-tier sound, it's just engineered a lot smarter.
Moving right along to Section 2, Required Main Components. Let's look at the actual building blocks we need.
All right, here's your shopping list. First, we've got a 24-volt, 8-amp switch-mode power supply. That's the heart powering the whole shebang. Next is our main TPA 3116D2 Class D amplifier board. We're going to pair that up with an SMD-based TL072 tone board, which lets you perfectly dial in your bass and treble. And to top it off, an E-Star USB Bluetooth module. What's really great about this specific E-Star module is its clean, white display, and, thankfully, it completely ditches those incredibly annoying voice prompts that scream Bluetooth connected every time you power it on. The source really emphasizes using these high-quality, clean, Indian-made boards, because that right there is the secret to getting absolutely zero background hiss.
Let's zoom in on the brains of our audio output for a second. This amplifier board uses an original Texas Instruments chip. This specific IC is basically bulletproof and guarantees a pristine output of a true 50 watts per channel, so 100 watts total, with extreme clarity. And remember, since it's a Class D amp, it pulls all this off without some massive heatsink weighing it down.
Okay, Section 3, Cabinet and Board Arrangement. Let's talk about how we actually fit all this together inside a compact 7-inch cabinet without creating a complete wiring nightmare.
Since we're packing all this power into such a remarkably small space, careful layout is totally crucial. You're going to want to drop your power supply at the back, keeping it nice and close to the AC wall input. The amplifier board sits neatly right in the middle, and the tone board goes right up at the front where your control knobs will live. The trick here is to physically place them all down first, mark the holes with a pencil, drill them out, and then secure everything using elevated standoffs or spacers. That way the boards never accidentally short out against the metal bottom. As for the front panel, the assembly is super neat. You just take your Bluetooth USB module, snap it into its plastic side mounts, and lock down the edges with a bit of quick-dry gum. Then, you fasten the whole custom black acrylic front panel to the cabinet using some sleek Allen screws. It seriously gives the entire unit this brilliant professional retail finish, and you only need basic hand tools to pull it off. All right, on to Section 4, Audio Control Wiring. Now, what's really interesting about this slide is how it breaks down the actual signal flow. It really helps to think of the audio like water flowing through pipes. It all starts at your USB Bluetooth module. From there, it flows straight into the tone board, which is where you shape that bass and treble.
Out of the tone board, the signal passes through your volume and balance controls to set the levels. And finally, it dumps right into the main amplifier input to be blasted out to your speakers. If you just keep that conceptual flow in your head, you literally can't get lost when you actually start soldering wires.
And to actually control that audio flow, this build uses some very specific components. We're talking 100K dual potentiometers for the bass and treble, and 47K dual potentiometers for the volume and balance. Now here's a massive pro tip from the source material. Use dedicated little PCB mounts for these control knobs instead of trying to blindly solder wires directly to the tiny pins. It keeps your build incredibly clean, structurally sound, and stops you from accidentally snapping wires off down the line.
Section 5. Power supply and connections. I know the power loop is usually the most intimidating part for hobbyists, but I promise you, it's wonderfully simple here.
Look at how clever this power sharing loop is. Your power supply kicks out 24 volts, right? You route that directly to your amplifier. Now, instead of running a bunch of messy wires all the way back to the power supply to power the other boards, the amp board acts like a hub. You just tap 24 volts straight from the amp board's terminals to power your tone board. And it gets better. This specific amplifier board has a built-in step-down regulator. That means you can tap exactly 5 volts straight off it to power your Bluetooth USB module. You don't have to buy any extra converter chips, and the inside of your cabinet stays super clean.
Oh, and we definitely can't forget aesthetics. The source shared this awesome quick customization tip. The power supply also happens to have a 12-volt output tap. If you wire a tiny 3mm blue LED with a 1K resistor straight into that 12-volt tap, you can pop that LED right behind the volume control knob. It lights up the ring around the knob and gives your DIY cabinet an incredibly high-end, premium retail look. Such a cool touch.
Almost done. Section 6. Final testing and result. Let's see this thing come to life.
The source text makes a massive point of emphasizing this next part, and honestly, it completely validates the entire project. In cheaper builds, you usually get this annoying static hum sitting in the background when no music is playing. But thanks to that clever power routing and those high-quality Indian-made boards we used, this build is dead silent. I mean, even when paused with the volume cranked up, there is absolutely no hissing, humming, or unwanted noise. Just pure silence waiting for a signal. And when that signal actually hits, well, the power is staggering. Despite its tiny footprint, the source shows this exact amplifier effortlessly driving massive 300-watt tower speakers per channel. It pushes punchy, room-shaking bass and crystal-clear treble without even breaking a sweat. It really proves just how immensely capable that TPA3116D2 chip is.
So, the crucial point is really this. If you look at a traditional Class AB setup, you're talking about hours of complex soldering, super heavy parts, and a constant risk of introducing annoying, humming noises. Contrast that with this modern Class D build. It totally relies on clean, plug-and-play modules to deliver audiophile-grade audio. And incredibly, the entire physical assembly and wiring can be knocked out in about 30 minutes. It just completely changes how you think about high-fidelity sound, doesn't it? You clearly don't need a massive budget, and you certainly don't need an engineering degree. Now that you know you can build an audiophile-grade, hum-free 100-watt stereo for half the price in just 30 minutes, what audio project are you going to tackle next? Thanks so much for hanging out with me on this explainer. Keep exploring, keep building, and I'll catch you next time.